Okay, so our next lesson is lesson 2.5, and we're going to be talking about the addition and subtraction properties. Pretty straightforward. It's exactly what it says. So if I look at this segment, we know that AB is congruent to CD. And we know that because AB is 7, and we know that CD is 7. Okay, AB is congruent to CD. But what we can also notice is that BC is here in the middle. What if I wanted to look at AC and CD? Okay, so not CD. AC and BD. Okay, and then we look here. Okay, what do we notice about the length of AC? Well, we notice the length of AC is 10, and we notice the length of BD is also 10. So we know that they're congruent. So what happened? Well, we added this segment, BC. And that's what our first theorem says. If a segment is added to two congruent segments, so if BC is added to AB and CD, then the sums are congruent. Okay, so if I take there we go. So if I take AB, and I know that AB is congruent to CD, and I add this little piece in the middle, we can say that AC is congruent to BD. Now notice I crossed off the addition property. When we use these properties, just like everything else, we have to use the full if-then statement, okay? I'm going to post an Edpuzzle, and the Edpuzzle is really good, and the guy does a really great job of explaining addition and subtraction, but he just says addition property and subtraction property. For your homework, you are going to make sure that you have to write out the full if-then statement, okay? Okay, so then our next theorem deals still with addition. We're going to cross this off. We're not super worried about the theorem numbers, okay? But this is dealing with angles. So if an angle is added to two congruent angles, then the sums are congruent. So we want to look at angle EFJ, and we see that that's congruent to angle HFG. Okay, so this angle is congruent to this angle. Okay, so then we look and we see, what if we added this angle? Okay, so now I've got this whole angle, because I added the 50 plus the green, and this whole angle. Okay, so now because I added angle JFH, I can say that angle EFH is congruent to angle JFG. Okay, I'm sorry if you hear my dog growling. He just woke up. Okay, so that's the first part of the addition property. Okay, so we say that we've got two congruent segments, and then one segment is added to both of them. Or we have two congruent angles, and one angle is added to them. So our next theorem says, so we're going to cross this off. If congruent segments are added to congruent segments, then the sums are congruent. Okay, so let's look at this parallelogram. So we can see just by the markings, we can see that KR is congruent to SO. And we can see that RM is congruent to PS. Okay, so what the theorem says, if congruent segments are added to congruent segments, the sums are congruent. So I can now say that KM is congruent to PO. Okay, again, same thing with our next theorem with angles. Okay, so we're going to cross this off because that doesn't matter. We're going to cross this off because we're not going to use that yet. If congruent angles are added to congruent angles, the sums are congruent. So we're going to look right here. We see that angle TWY is congruent to angle TXY. Okay, and then we see that this baby angle, so angle YWX is congruent to angle YXW. Okay, what the proofs are going to look like, it's going to say prove angle TWX is congruent to angle TXW. Okay, so this whole angle is congruent to this whole angle. Well, we're going to use this theorem. If congruent angles are added to congruent angles, the sums are congruent. Okay. We'll look at subtraction properties now. Okay, so just like with addition, we're going to also have subtraction. So if I look at this first one, we notice we see that AC is congruent to BD. Okay, what do they have in common? Well, we notice that they have BC in common. So what the subtraction property says is if two segments have, like if I subtract one common segment from two congruent segments, then I can say that AB is congruent to CD. Okay, if I look here, down here at this picture, okay, we know that this whole piece, so KO, is congruent to KP. We see that ON is congruent to RP. By the subtraction theorems, now we can say that NK is congruent to RK. Okay, and we'll talk about the wording in just a second. Okay, so again, same thing with angles. I've got this whole big angle here congruent to this whole big angle here. We notice that they have this angle in common. I can subtract that out and then show that this angle is congruent to this angle. Okay, here, again, we've got a big angle. We see that within that, the smaller angles are congruent. So I can subtract to then say that this angle is congruent to this angle. Okay, so the wording. Again, we're not going to use subtraction property. We're not going to use the theorem names. So it says if a segment or an angle. Okay, so when we look at, so up here, they broke up the addition into segments and into angles. Here, we're just going to say if a segment or an angle is subtracted from congruent segments or angles, the differences are congruent. Okay, and then the next one, if congruent segments or angles are subtracted from congruent segments or angles, the differences are congruent. So here it's one segment or angle. Here is congruent segments or congruent angles. Okay, so I'm going to make this a little bit smaller so I can get the picture. Okay, so this right here, okay, if a segment is subtracted from two congruent segments, the differences are congruent. Here, if an angle is subtracted from congruent angles, the differences are congruent. The bottom theorem, if congruent segments are subtracted from congruent segments, the differences are congruent. Okay, and then this one, if congruent angles are subtracted from congruent angles, the differences are congruent. Okay, so again, it's always going to be you're either adding one piece to congruent angles, or you're taking congruent angles and adding them together, or with subtraction, you're taking one piece and subtracting it out, or you're subtracting two pieces out. Okay, so here's what we want to pay attention to. An addition property is used when the segments or angles are greater. Okay, so if it's getting bigger, we're going to use addition. Okay, the subtraction property is used when they're getting smaller. So we want, this is our keyword here, the conclusion. Okay, so what we're trying to prove, if it's getting bigger, if my angles or segments are getting bigger, we're going to use the addition property. If my segments or angles are getting smaller, we're going to use the subtraction property. Okay, so let's take a look at this. Okay, so given AB, so this is congruent to EV, or I'm sorry, EF, FE, it doesn't matter. AB is congruent to FE. BC is congruent to ED. Now they marked this graph or this picture for us. If they didn't, we would have to do that. We want to prove that AC is congruent to FD. So this is given, this is given. So how are we going to say that AC is congruent to FD? Well, we notice it's getting bigger. So if congruent segments are added to congruent segments, then their sums are congruent. And if you wanted to shorten this, like, I wrote out congruent there. Like, if you wanted to use the congruent symbol all the way through, that's totally fine. Okay, so we've got congruent segments, congruent to congruent segments, then the segments are congruent. Okay, so let's look at the next one. So it says given GJ, so GJ, so this whole piece is congruent to HK. We want to prove that GH is congruent to JK. Okay, so if we look at this, so we've got this whole piece is congruent to this whole piece. We want to prove that this is congruent to this. If we look at it, it's we've got a big piece, we're going to a smaller piece, we're going to use subtraction. So the first statement is given. The second statement, or the second reason for our statement, if a segment is subtracted from congruent segments, then their differences are congruent. Okay, again, we took two big congruent statements, or segments rather. We subtracted out this middle part. So one segment got subtracted out. So now their differences are going to be congruent. Okay, so let's take a look at some angles. So NOP, so NOP is this whole angle, is congruent to NPO. Okay, ROP is congruent to RPO. We want to prove that NOR, so this angle here, is congruent to NPR, so this angle here. Okay, so again, I'm starting with a big angle, two congruent big angles. I have two congruent angles, and I want to prove that the small ones are congruent, so we're going to use subtraction. This is given, this is given. Now we're going to say if angles are subtracted from congruent angles, then the differences are congruent. Okay, again, we went big angle to small angle, so we're going to subtract. Okay, looking at this one. So the conclusion is right here. We want to conclude that AC is congruent to BD. Okay, they told us that AB is congruent to CD. We want to prove that AC, they told us that AB is congruent to CD. We want to prove that AC is congruent to BD. Okay, so when we look at the picture, if we just add this one segment, we're going to have congruent segments. So my reason for the first one is given. For my second one, if a segment is added to congruent segments, then the sums, because it's getting bigger, the sums are congruent. Okay. So with these proofs, okay, again, if they're getting bigger, we're going to use addition. If they're getting smaller, we're going to use subtraction. And it's either going to be that we are, so if we go back all the way up here, okay, with our theorems, here we go. Okay, if a segment is added to congruent segments, okay, so there's going to be one piece that's added to the both, or if two segments are added together to make, so if congruent segments are added to congruent segments, or congruent angles, okay, so again, there's just two differences, two different things that we're looking at in this section. With subtraction, again, if a segment or angle is subtracted, so I'm taking two angles, I'm subtracting like the middle part, or I have two congruent angles and I'm subtracting two congruent angles, okay? So let's go scroll down. Let's look at these questions. Okay, it says name the angles or segments that are congruent. Okay, so for letter A, they show me that the DE is congruent to CB. They show me that EA is congruent to BA. Okay, by the addition property now, we can say that DA is congruent to CA. Okay, let's get the wording right. If congruent segments are added to congruent segments, the sums are congruent. Okay, here we've got this angle. Oh, this angle is congruent to this angle. This angle is congruent to this angle. So we can say that this whole angle is congruent to this whole angle. If congruent angles are added to congruent angles, their sums are congruent. Okay, so now it says name the segments that are congruent by the subtraction property. Okay, so they told us that RT is congruent to SV. Okay, what do we notice that they have in common? They have in common this piece. So now I can say that RS is congruent to TV, because if a segment is subtracted from congruent segments, the differences are congruent. Okay, here, again, I have a big angle and a big angle that are congruent. I know these small angles are going to be congruent. So what I can say is that this angle is congruent to this angle, okay? So angle YXZ is congruent to angle CBD, because if congruent angles are subtracted from congruent angles, the differences are congruent, okay? So what I want you to do now is I want you to get started on your homework. Again, this is going to be due on Monday, and we're going to talk about everything. We'll get everything squared away with 2-4 and 2-5. I am going to post another Ed puzzle. Again, it just is a different explanation. I just want you to remember that you have to use these full theorems. Okay, we're not going to use shortcuts yet. Eventually we can, but right now you have to write out the whole theorem. Have a great weekend.